So let's get to it. Let's just give a brief overview of what we are going to do. We will be loading an orthomosaic constructed from a drone image. As we said before, this is just a basic use of some basic functions to load images, but this is also a way in which we get access to the data that the forestry people collected for us. We will also load several ground truth annotation images. Those, again, are just simple binary images that we will load in mostly the same way as the first one, but they will contain the expert knowledge of the forestry people, and we are going to use this knowledge in this session. We will use the annotations in two ways. We have annotations that first mark where each particular bush is, because all of these images are showing us a section of Zhao Mountain where we want to study the presence of the different species of subalpine bushes. So we have two types of annotations, and the first one shows us where the bushes are. And we also will use the second type of annotation that shows us where each species of bush is distributed. So with one type of annotations we will know where the bushes are, and with the second type of annotation we will know what species each bush belongs to. And we are going to be doing all of this automatically using things like cutting parts of images, using the fact that images are just matrices with pixels that we have seen, using ways to find the coordinates of convex connected component regions in images, which is something a little bit more sophisticated, but that we will solve with a simple call to an OpenCV function, and then we will bundle this together so that we end up understanding the data that we have, feeding it to the computer and processing it in a way that allows us to go over it automatically, and to, in the future, in following sessions, feed it to deep learning networks. But all of this so far still sounds a little bit theoretical, so let's have a proper look at what we want to do. First of all, we have we will be looking at this in just a second in more detail inside of the Jupyter Notebook, but it's always important to really have a look at the data and get a feel for what you are doing. So I have just gone to the folder that contains my files, and you can do that too by downloading them using the links that are provided in the Jupyter Notebook. And I'm just looking at them. So this is the site5mosaic.jpg file. Okay, and as you can see, it shows an orthomosaic, which is a collection of pictures taken with a drone and then put together using photogrammetry software, Metashape in our case. And we have a very detailed, in terms of a spatial resolution, each pixel here represents about 1 centimeter in the real world of a large area of the forest. And we can see that, well, this area is interesting because we have all of these white guys which are just dead fir trees. There used to be a huge fir forest here, it's no longer there. There was an insect infestation and most of the fir trees died. And we also have lots of subalpine bushes of different species. Okay, and we are going to be dealing with this and trying to recognize what species they belong to and so on and so forth. But in order to do that, well, we need to know where they are, and we need to know what part of the orthomosaic of the large image corresponds to each bush. So we will use the annotations that the forestry people have done for us. And here let's just open one annotation file, okay, which is, well, a binary file of the same size as the original mosaic, okay, which is made up of lots and lots and lots of dots, okay, and each dot represents the location of one subalpine bush, okay. But let's just move about a little bit so you can see that there are lots of dots around. And well, this is not very useful, so we would like to see where the dots are in the bigger picture. So if we are using image visualization software such as GIMP, we can do tricks like use opacity of the binary layer containing the annotation. So I'm just going to, give it a 50% opacity value. Let's just do a little bit less. Let's do 20%. Okay, so I can still see the dots here, but then I have a much clearer view of what bush each dot is signaling. Okay, so this is a very simple example of what we will be doing. We will be using our drone acquired data and the expert annotations that the forestry people have done for us to convert this initial very huge orthomosaic that has a very high level of detail. Let's go as deep as we can into the detail. Okay, here I still get some texture, although I get pixels. Each pixel represents about 1 centimeter in the real world. We will use this data with these annotations to transform this into something that a deep learning network can use, and we will do it by using simple computer vision functions that you already know.